My name is Ahmed Raza, and now that is derivative a lamp post casts a shadow of man walking away from it. So the statement is a 1.8 meter tall man walks away from 6 meter lamp post at the rate of 1.5 meter per second, and the light at the top of the post casts a shadow in the front of the man. So the question is, how fast is the head of his shadow moving along the ground? So we have the ground and a lamp post, and we will put a lamp that's at the top of the post. As you can see that the sum of the light that leaves the lamp strikes the ground, when there is a man standing there, the light that hits his back and does not reach the ground, then thus producing a shadow in front of him. So the shadow goes from his feet to a point that's determined by the line that passes from the lamp along to the top of his head, and then onto the ground. Since we are really only interested in the shadow, so let's focus on that along with the line that determines its length. So the man is basically is 1.8 meter tall, and the lamp post is about 6 meter tall. So let's cast the distance from the lamp post to the man is x, and the distance from the lamp post to the head of the shadow is L. So as the man walks, his x position changes at the rate of dx over dt, the rate at which x change with respect to time. So we are looking for the rate at which the position of the shadow's head moves along the ground, which is dl over dt. So the rate at which L changes with respect to time. So now clearly, the faster the man walks, the faster the head of the shadow moves too. That is larger dl over dt is. So the rates dx over dt and dl over dt are somehow related, and we have to find the relationship between them. So specifically we have told that the man walks is at 1.5 meters per second, which is the value of dx over dt. So now we are looking for the corresponding value of dl over dt. So to find a relation between dl over dt and dx over dt, for this problem we need to develop an equation that we will use similar triangles. So in our figure you can see that we can see one small triangle embedded in another bigger triangle, which is big clue that we will use similar triangles in our solution. So notice here that both small and large triangle are right angle triangles, and furthermore the upper angles of the two triangles are equal, and the base angle is actually the base angle is actually identical in two triangles, since all three angles in the two triangles are equal, so the triangle are similar. So we can develop a relation among their lengths. So to do so, remember that man's height is about 1.8 meter, which we will add to our small triangle. And the lamp post height is about 6 meter, so which goes to the large triangle. So the base of the large triangle has L, while the small triangle has length is L minus x. So with those quantities in place, quantities in place, we can remember that when you have similar triangles, so the ratio of their base lengths equal to the ratios of their heights. So here the ratios of base length is L minus x over L is equal to the ratios of their heights 1.8 divided by 6 so numerically that equals to 0.30 meter. So numerically that equals to 0.30. We can now solve for L in terms of x with just a little algebra. So we first move L from the L denominator on the left over to the right. So we have L minus x is equal to 0.30 L. So then collecting all of L's on the left, moving x to the right, so we have L minus 0.30 L is equal to x. So we have a value of have a relation that we need between L and x is equal to 0.70 L. So take derivative with respect to time on both sides for our equation. So we dx over dt is equal to d over dt 0.70 L. So we can here we can pull 0.70 out of the derivative, since that is a constant. So as we know that our dx over dt is equal to 1.5 meter per second. So we want dl over dt. So here dl over dt is equal to 1.5 divided by 0.7. So we have our final answer, that is 2.1 meter per second. So this is the answer. Thank you.
Actually, AB initio method is the first principal rule that is used for explaining that is used for finding the derivative, or we can say that it is a fundamental method that is used for finding the derivative of a function, say y, which is equals to f of x with respect to x. This is called as AB initio method. So let me explain this with the help of my figure. This is a figure. Let's say this is a coordinate plane, and this is the coordinate this is the x-axis, and this is the y-axis. These are the y-axis. So if we take a point x on the x-axis and a point y on the y-axis, and then we are going to join them at a certain point. This point is called as P. And if we say that if we increase x with a small amount, say del x actually means the rate of change, that we are going to change x and increasing it by a small amount. So we are going to add it because we are increasing it, and we are going to add a small amount. So there is a del x, which means a small amount, change of small amount. So x is increasing by a small amount. If we increase an independent variable, then automatically the increment in the independent variable also occur. So here we are saying that this is the change, this is x plus del x, then there is also an increase in y axis. There is also increase in y, dependent variable. Here is y, and here is the original first point y, which we have joined with x. But now after increasing, we have a small amount in x, the axis, the y is also going to be increased. Look, after increasing x at point q, the y is also increasing by an amount of del y. So this is the point q at which the x is increasing, and due to the increase in the x, the y is also increased by an amount of del y. So now we move toward that we can write it as, at the point P we have the coordinate axis x comma y, but when we have increased a small amount, then the point q becomes x plus del x, comma y plus del y. This is the increase. So let's move forward. If we say that at the point P, the function was y is equals to f of x. At point P, function was f is equals to y is equals to f of x. But at point Q, there is a change in the function, which means that there is an increase in the function. And what we meant by increase, that y becomes y plus del y, and here the x also changed, that is x plus del x. And now we have seen that firstly it was x, and then by increment it becomes x plus del x. But when we at point Q, here at point P, it was function y is equals to f of x. But at point 2, after increment of a small amount, the y becomes y plus del y, and the x becomes x plus del y. Now by taking let's say this is the equation 1 and this is the equation 2. Now taking the difference, equation 1 and 2, what we can say is y plus del y minus y is equals to f of x plus del x minus f of x. So here plus y and minus y are cancelled, del x minus f of x. So this was the change in the x. If we subtract the equation 1 and 2, then we get a change in the value of y. Then we get a change in y. This is a y. Now we have to look for the change in x. So for the change in x is what we have seen, that this is the point x and this is the point x plus del x. We have increased an amount. So for finding the change, that how much we got a change by increasing x by a small amount del x, then we should subtract this quantity from this quantity, final minus initial, because this was the initial point, this was the final point, and we got an increment in the final point. So for subtracting the initial point from the final point, we get a change. Let's say the final point was x plus del x and minus x. The change in x is final minus initial. So these both were cut down, and now this becomes equation 3 and equation 4. And now as we can see that the average rate of change in y per unit change in x, average rate of change of y per unit range in x in the form of the line PQ, because the line PQ, that this line PQ is called as secant line PQ, and we are getting a change at this line PQ. So this line PQ, the rate of the change is happening at this slope of the tangent of the secant line PQ. Here there is a rate of change, that is from x to x plus del x. There is a change from y to y plus del y. There is the change occurs between the points P and Q. So the point PQ is represents the slope of the secant line, also represents the slope slope of secant line PQ. Now by dividing equation 3 and 4, we get, here is the equation 3 divided by del x which is equals to here, or we can write over here, next page. So by dividing equation 3 by equation 4, we get a first principle rule. So this is the first principle rule and AB initio method, both are the same thing. So this is the derivative rate of change. We have explained the derivative explanation with the help of the AB initio method. So this was all about the topic AB initio derivative explanation with the help of AB initio method.
Assalamu alaikum sir, I am Muhammad Danish and I was given the question number 14 of the quiz to explain. So let's begin. Sir, I will explain the ab initio method to derive the formula of f of x power is equals to n x power n minus 1. So sir, after some calculations we get df delta f over delta x is equals to f into x plus delta x minus f of x divided by delta x. Sir, I did not mention those calculations, but those are very basic as we studied in our second year. So we move further, sir. As we know that here we have x is equals to xn fx, so which is x power n. So sir, instead of x plus delta x we will write x plus delta x power n as written here, and also instead of minus fx we write x power n as written here, f of x is equals to x power n, and delta x will come as it is, where n is equals to 1 2 3 4 5 to whatever. So sir, now we will be applying the binomial theorem on this x plus delta x power n. So sir, we see that x power delta x is multiplying n times. So sir, we will just mention it here to make it more clear, x plus delta x into x plus delta x up to x plus delta x to n factor as written, as mentioned here. So sir, moving further we will multiply this to simplify it. So sir, we will get x n power n x power n minus 1 delta x is equals to delta square x square. Now sir, delta square x square are high ordered powers of delta x which are unimportant, so we call them junk values. So sir, we will not be beyond x delta square x square, we will not be writing these junk values. Instead of that we will just mention junk values. So sir, now we will put this this part of the equation in above equation here. So sir, x plus delta x power n will become x n power nx minus 1 delta x, and instead of those delta square junk values we just write junk values, and this minus x power n will be written as it is, minus x power n and delta x. So xn will cancel out with this minus xn, and we will get nx power n minus 1 delta x plus junk values by delta x. So we will write these both separately, nx power n minus 1 delta x divided by delta x plus junk value divided by delta x. So delta x will cancel out with delta x, and in the next step we will have this. So now sir, we have to apply the limit. So we will apply the limit. So sir, applying here the limit, delta x approaches to 0, delta x power n divided by delta x is equals to nx power n minus 1 will be written as it is because it does not have any delta x. So this part of the equation does have delta x, so we will apply limit on that and this will become 0. So whole junk values up to I don't know what will become 0. So this will not be written, and we proved that d by dx of x power n is equals to n x power n minus 1. So this was my explanation, sir. I hope you approve it. Thank you so much, sir.
Assalamu alaikum. Now I am going to solve a derivative application. For this purpose, consider a building having shadow at any particular time. So now I'm going to draw a graph of the building. So consider this is a building, and here consider a man of 6 feet is standing here, and now the shadow of the building is falling here. So the consider this height of the building, let's 20 feet, and the base is of 30. We can name this h and here x, let's say. Now we have to find the derivative when x is equal to 20, because it's the length of this building. So we have y here, and base is 30, so both are perpendicular. So we can write like this: y30 is equal to, here is 6, the height of man is 6 feet, so 6 divided by 30 minus x. Now applying the derivative on both sides, so 1 by 30 dy by dx is equal to, by applying derivative here we will get minus 6, 30 minus x minus 2 minus 1 dx by dt, and now dy dt is equal to 6 divided by the value of x is 20, so minus is 30 minus 20, and 30 minus 20, there is square root when it will come to the denominator, and 30. By solving this we will get minus 1.8 answer. So this is